Hello everyone. I welcome you all to Startup Academy, your online gateway to success in ISS exam. So we have been discussing in the previous lectures about paper 3, which is descriptive type. And since this paper 3 is a tough one, this paper 3 is tough amongst all the other three papers. Among the four papers, this one is the toughest one. So if you continuously keep on watching our videos regularly and keep on doing what we are doing in the class, then you will be able to resolve all your queries. And you still have any doubt, you can ask in the comment section. And we have picked this paper because if you will do this, because this, all the students find it very hard to clear this paper or to understand what is going on in this paper. So we have picked this to show on YouTube so that you all will be able to do without any cost. So I would urge you all to keep on watching the series and keep on doing it with us. Now we have been doing in the previous lecture, we have covered simple linear regression model, multiple linear regression model, problems related to the both simple linear regression model and multiple linear regression model. So the problem here that we are dealing with is multicollinearity. In the previous two lectures, we have discussed heteroscedasticity and autocorrelation. Today, we will consider another problem that which is multicollinearity. This is another Gauss-Markov assumption that we have stated, and this is the when the model does not follow that assumption, when we arrive to the problem known as multicollinearity. Suppose we have models like this. So multicollinearity says that when two or more explanatory variables are highly correlated. Explanatory variables, or we can write it as independent variables. Highly correlated with each other. Suppose we have the model yi is equals to beta naught plus beta 1 xi plus epsilon I for all I goes from 1 to n. Now here if I write the covariance of xi and xj is not equal to 0. That means xi depends on xj. For all I not equal to j goes from 1 to n. So this is our multicollinearity problem where the explanatory variable, or we can say independent variable, are dependent are dependent on each other. And this thing does not follow Gauss-Markov assumption, and hence our model is not completed and we cannot find the estimates. So moving on to further, what are the kinds of model that follows this? So I am taking four examples. So first one is yi, we can say xi is equals to alpha naught plus alpha 1 xj. Xi is equals to beta naught plus beta 1 xj plus epsilon. Xi is equals to beta naught plus beta 1 x1ij plus up till beta p x pj. And another example is xi is equals to alpha naught plus alpha 1 x1j plus alpha k x kj plus epsilon. All these four models tells us that xi depends on xj. Here also second model xj and error also, and here the series of xj and here the series of xj plus the error. All these four models are following multicollinearity. So there are two kinds of multicollinearity. There are two types of multicollinearity. First is perfect multicollinearity. Now, what do we mean by perfect multicollinearity? Suppose we have the model xi is equals to alpha naught plus alpha 1 xj. Here, xi is directly dependent on xj, and hence we can say the perfect multicollinearity exists. This equation is more of like y is equals to mx plus c. When we have a model which represents this straight line equation, then our model follows multicollinearity, and here the correlation coefficient has the value plus minus 1. This is our perfect multicollinearity. Now, the second type of multicollinearity is near to perfect. Near to perfect multicollinearity. So, if we have the model xi is equals to beta naught plus beta 1 xj plus epsilon. Here xi does not only depend on xj, which is another explanatory variable, it also depends on an error term. And so, due to the presence of error term, the perfect multicollinearity goes from perfect to near to perfect. And here we can say that our correlation coefficient, modulus of absolute value of our correlation coefficient is always less than 1. These are the two types of multicollinearity. So in this, all these four models, only here perfect multicollinearity exists. And in these three, near to perfect multicollinearity exists. Okay. So I hope you all have got what is multicollinearity and what are the two kinds of multicollinearity. And now we will start with detection method. First of all, we will have to detect. Then we will see. Then we will see what are the remedies, and then we will see what are the questions that has been asked by the ISS exam in the previous year. So detection methods. So detection method, the first method is graphical method. We will, in this one, we will draw the graph between two explanatory variable, which is xi's and xj's. So if our graph goes like this, or this, then we can say that our model follows near to perfect multicollinearity in both these graphs. And if our model is like this, that somewhat it remains constant. So here we can say no multicollinearity exists. Data is randomly selected, so no problem is there in the data, and hence no multicollinearity exists. Now if we draw the graph between xi and xj's again, if the graph goes like this or this, then perfect multicollinearity exists in both these graphs because the lines are straight and there is no randomness of data. And if the graph goes like this, then there exists no multicollinearity. I hope this is clear. Now the second method is correlation method. Now what does correlation method says? Correlation method says that we have to find firstly the correlation matrix, and then afterwards we will find whether our we will get the value of r square, which is correlation coefficient, and hence we can find whether our model is contains multicollinearity or not. So first thing is correlation matrix. Let us suppose x dash x is given by s, which is S1 square, S12 till S1p, S21, S2 square, S2p, SP1, SP2, SP square. This is our correlation matrix. Now we can write the variance covariance matrix as S1 square, S21, SP1, S12, S1p, S2 square, S2p, SP2, SP square. This is the under root of this only, the correlation matrix. Now moving on to diagonal matrix. We will calculate the diagonal matrix D. S1 square 0 0 0, S2 square 0 0 0, SP square. This is our diagonal matrix. Now we will find this value of diagonal matrix, which will be nothing but 1 upon under root S1 square 0 0 0 1 upon under root S2 square 0. 1 upon under root SP square 0. This is our this value. Now we will multiply these three variables, which is for R we will multiply D inverse R, which is correlation coefficient. This will be the value of our correlation coefficient. So taking this value, SP1, SP2, SP square. From here we will get our value, which is R. Now the test says that if the value of R is greater than 0.75, then if the value of R is greater than 0.75, so on multiplying these, we will get the values of this variable as R1 square, R12, R1p, R21, R2 square, R2p, RP1, RP2, RP square. These are the values that we will get of our correlation coefficient. So if the test statistic says if the value of Rij is greater than 0.75, then near to perfect multicollinearity exists. And if the value of Rij is equals to plus or minus 1, then perfect multicollinearity exists. and hence we can find whether our model is perfectly multicollinear or near to perfect multicollinear. Now the third one is by SLR model. What is SLR? Simple linear regression model. Suppose we have the model yi is equals to beta naught plus beta 1 xi plus epsilon I for all I goes from 1 to n. This is our model. Now in the SLR model, firstly we will find the estimates and then we will find the value of R square, which is correlation coefficient of the model, and hence after that we will calculate. So by OLS estimators, we get beta naught cap and beta 1 cap. Now from here we will calculate the value of R square, which is nothing but 1 minus residual sum of square upon total sum of square. Or this R square can also be written as explained variation upon total variation. Either of the two you can write. So the test statistic here is if R square is greater than 0.90, then near to perfect multicollinearity exists. And if the value of R square is nothing but plus or minus 1, then perfect multicollinearity exists. So these were the three types of detection method. First one was graphical. Uh, the second one was this SLR model, and the third one was correlation matrix. All these, I hope, all these methods are clear with you. And we will do some remedial problems, and after that we will solve the question in the next class. Hope you are getting what we are teaching in the class, and if you have doubts, you can write it in our comment section, and only the relevant doubts will be answered. So thank you all and keep on preparing for your exam.